Let's start. Okay, so today we're going to go back over, we're going to do a quick memory review over grams to moles, and then we're learning two new pieces, okay? Yesterday we discussed that if you have grams has to be here of any compound or element, and that always and forever equals 1 mole. You multiply and divide by the molar mass. Molar mass is found where?
The atomic mass.
On the
Periodic
atomic
table.
mass periodic table. For some of y'all weren't here yesterday, so we're going to have to get back to that piece. The new stuff today is this. You have a worksheet that you picked up is the mole and Avogadro's number. I'm going to randomly show you an example of how that might look. We know that 1 mole of any substance is always and forever equal to molar mass. It's also equal to Avogadro's number, which is this. Now, Avogadro's number accounts for several different words that mean the same thing. This is 6.02 times 10 to the 23rd particles. It also stands for molecules.
Does the E, is it exponent?
E is exponent, and I'll show you how to input that in your calculator to save your soul. Atoms,
I ain't got no calculator.
ions, and you will even see them say very rarely formula units. That is no different than you calling a refrigerator a fridge or an icebox. It means the same thing.
Hey, I figured
So-
out the E.
1 mole of anything is equal to Avogadro's number. Okay? So today, we are going to do this component, and we're also doing another conversion. Not only does 1 mole equal Avogadro's number, 1 mole also equals, of any gas, at standard temperature and pressure, 22.4 liters of that gas.
Does it also equal the atomic mass of that?
It's also equal to the atomic mass. So it's kind of like a conversion of saying there's 12 months in 1 year. There we also know there's 365 days in 1 year. These are just conversions. Are we good so far?
No.
Okay? So here are some examples so that you know how to start and set up your worksheets. If I were to give you this example, if I were to give you 4 moles of sodium, and I want you to tell me how many atoms of sodium do you have? I want to know how many atoms this is. I set up my railroad.
1, 4.
We've got to set it up.
Oh.
You have to put moles in the bottom right.
What unit I have here has to go
There.
here. So I have what unit?
Mole.
So down here I have to have, whose moles are they? Sodium. Now listen, until I tell you otherwise, always and forever, what number goes next to the word mole?
1.
1. Now, I just told you conversions. I said that 1 mole is equal to Avogadro's number. I said 1 mole is equal to
2.22, something like
22.4 liters. And 1 mole is equal to Avogadro's number, which is 6.02 times 10 to the 23 particles, molecules, atoms, ions, formula units. I asked you for atoms. So what you want goes on top. What number goes next to the word atoms?
that. NA.
6.02.
Wait.
Avogadro's number.
Oh,
Why?
because it says
1
atom.
mole of anything equals that many atoms. 6.02 E23 atoms. Always and forever. Now, I continue on doing what we did yesterday. we are going to multiply the top two and divide by the bottom. So someone input that in your calculator and tell me what you get.
I want to do it.
How do you do the exponent?
You
Oh,
press, you
exponent.
press second and then this one right here.
Okay, here's how you do it. I want you to do this with me 4 times
Miss, I ain't got no calculator.
4 times what?
10.
You can go get that
4
one.
times
This is gonna be cool.
6.02. Stop when you get there and I'll tell you how to get that.
Wait, why can't you just put the 23 as an exponent and not put the E?
Because it will work.
Can you just put like
Why?
multiply by
The
10?
E like
No.
multiplies it by 10. It like multiplies it by 10 at the top.
Do exactly what I say. The reason for that is you have less computational errors. If you have a calculator like this, it's different. It has its own E button. If you're using mine, it does not. So ready, you have 4 times 6.02 as of now, correct?
Yes.
Yes.
You're then going to press the second button
Second.
and the number button right above number 7. It should say EE in blue.
See, I was right.
Press that. You do not need to put a times next to it. Nothing. It would be 6.02. You have your E sign, 23, enter.
2.08 times 10 to 24,000.
All right, 2 decimal places. What do we have? 2 point what?
2.41.
1.
E 24 atoms of Na. I've seen people do this today. Have the right answer, but they're leaving off their units. And of who?
Na, sodium.
Have to have all of it.
Wait.
You've got the times 10.
I did. I put the times 10. I put E.
Oh, that's
Too late.
Oh, so E means times 10.
E means times 10. It is your exponent. If you want to write times 10, that's correct. That's just a lot more writing than I care to do. Now, what if I were to give you this? We have 4.3 times 10 to the negative 4 molecules of carbon dioxide. And I want to know how many moles that is. Molecules is not moles. I set up my train track. What word do I have here?
Molecules.
So what word has to go here?
Molecules.
Big word. It's got a big number next to it. What number goes next to molecules always and forever?
6.02
E
23.
23. That always and forever equals 1 mole. I multiply and then I divide. Again, you're using E to represent your times 10. Do not put times 10 in the calculator because you run the risk of errors. Just do your second, that little button above number 7.
When it says 4.3 times 10, is that E?
Yeah,
Times
that's
10
E.
is E. And then you
Times 10 is E.
and then you put just negative 4. You would have put the negative 4 in the
Nope.
top.
E negative 4. So punch that in.
So don't put it as an exponent.
Nope.
4.
You don't have to do. You have less work to do when you do it this way.
You said put in E negative 4
Yep.
is 0.
Divided by 6.2. That one.
6.02. E 23. You get 7.4 E negative 28.
I get 7.14. Like yeah.
Moles of carbon dioxide. Box your answer. So far, so good?
One second.
Multiply and divide. Most people can do this portion. The problem they run into is they don't put it in the calculator properly and then all their answers are wrong. I've been teaching for 12 years. Trust me when I say the issue is the calculator inputting. Make sure you do what I tell you to. If you don't, you might get lucky. But you might also miss something on a test just because you accidentally put a time sign and you didn't need it. Okay? Now, what you would be learning tomorrow that you're going to learn today is how do we convert from volume to moles? How does that work? Okay. So what if I were to give you this? If I were to tell you you have 25.2 liters of oxygen gas, don't forget he's a Brinklehawk. And I want to know how many moles is this? Set up my train track. Now, what goes in the opposite box?
Liters.
Liters of who?
Oxygen 2. Oxygen.
O2 oxygen gas. Now, is there a conversion from liters to moles?
Yes.
Yes. 22.4 liters of oxygen at STP, means standard temperature pressure, always and forever equals 1
1
mole
mole
of
O2.
oxygen. My liters cancel, I'm left in moles, I multiply and I divide. What do you get at 2 decimal places? 1.13 moles of oxygen gas. It is simply a conversion that you're going to have to memorize.
Do you only add and multiply when it's grams?
No. Oh, do you add up the periodic table? Yes. The only time you use the periodic table for molar mass is if you're dealing with grams. We're not. These other two are easy because there's no calculation. It's a set thing. Well, what if I told you that you had 6 moles of hydrogen gas, and I want to know how many liters that is?
Then you put moles at the bottom and liters. You put 22.4 liters.
We have mole here. 1 mole of hydrogen gas has 22.4 liters of hydrogen. And then I multiply. And what do you get?
Well, 134.4.
134.4, do you agree? Liters of hydrogen. Those are your baby one-steppers. This is what I call those a one-step. It's a short and it's a sweet.
Sour and gone.
You're done for. Okay, it's easy. Don't have to think a lot. What I'm going to teach you on the next one, you are going to have to think because it's more steps. For example, if I told you we had 5 days and you tell me how many hours that is, that's a quick one-stepper, right? 5 days,
24 times.
in 1 day there are 24
Hours.
hours. That's a one-step to me. But what if I told you I have 5 days and I want to know how many minutes? I would have to keep doing what?
Add 3.
Divide.
1 hour is 60
Minutes.
That is a multiple step conversion. Look at your worksheet that has volume and moles on it. And look at question number 6. Question number 6. Can someone give that to me?
5 grams of hydrogen gas.
Is it 5.0 or 5?
5.0.
Of hydrogen?
Yes.
Okay, this worksheet says it wants you to solve for the liters. Is that what it says?
Yes.
You're either going from moles to volume or somehow. So all I need to do is follow my steps. What unit do I have here?
A gram.
So what has to go here?
Grams.
Grams of hydrogen. Now, we stated yesterday if we have grams, G has to look on the P table. What is the mass of hydrogen?
1.
1, and there's 2 of them, correct?
Yes.
So the mass of hydrogen is,
2.
well, what does that equal to?
2.
1 mole. That's the molar mass of hydrogen. So 1 mole of hydrogen gas, always and forever, equals 2 grams. Now my unit grams cancels, and I'm left in what unit?
Moles.
Is that what you wanted?
No, liters.
I want liters, so I gotta keep on keeping on. So this is a double step. What unit's here?
Mole.
So what has to go here?
Mole.
Okay. Does moles turn into liters?
Yes.
Yes.
22.4.
1 mole is 22.4 liters of hydrogen. My unit mole cancels, and I'm left in. Is that what you wanted, liters? Yes.
So what do we do
So
with
it's
all the
5
numbers?
times 22.4 divided by 2.
So what do we do with all of these pieces? Well, it's just like yesterday, it's a big fraction. We are going to take the top part and multiply. We are going to take the bottom part and multiply those two,
56.
and then we are going to divide the top and bottom. And what do you get when you do that?
56. 56
Yes.
mole. I mean,
56 liters of hydrogen.
The 2, because that's his molar mass. I look on the periodic table, and I know that 1 hydrogen is 1.008 grams. And since it's H2, he's a diatomic molecule, I'm gonna have 2 grams. That's the molar mass. And molar mass is 1 mole of anything equals the mass on the periodic table. Good question. So we have 56. Is that it? 56 point what?
Liters. 56 liters of hydrogen.
Is there a decimal?
No.
All right. Yes. Sydney, you have a question?
No.
Okay.
That wasn't hard.
That's a double step. That is what you were doing on Monday. Now, here's the deal. Tomorrow, you've already gotten both of your worksheets for today and tomorrow. If you get those completed, you have this mixed moles worksheet.
Nobody finished.
You gotta do it Monday. If you don't finish his homework. So if you have time, you can finish that, okay? Start on it tomorrow, finish it Monday. Yes, sir.
So it doesn't matter how many steps there is, it's always just on top of a
Nope. He said it doesn't matter how many steps there is. No. You keep going until you end up where you wanted to be. So if they would have wanted you to go to atoms, you would just keep doing it until you get to atoms.
And then it's always just gonna be top over bottom.
Top over bottom. Multiply all the top, multiply all the bottom, and divide the 2 pieces.
What's the worksheet for today? What one?
Both of them. Just do both of them, and
So do
you get to work on it tomorrow.
Today and tomorrow?
Are there any other questions?
No.
Next week we'll do percent composition. You review for your test, and Friday you have a test. All right.